Hi, my name is Scott Stafford. I'm a solutions architect with Databricks. I work in the US public sector. And today I'm going to tell you a fictional story to highlight the three personas of people that use Databricks. So we're going to be talking about tales from the New York City Taxi Operations Center. The three personas that we're going to be talking about today, of course, people that use the Databricks Unified Data Analytics platform fall into three main categories. First, we have Joe the analyst. Second, we have Elaine the data scientist. And third, we have Jane the data engineer. So imagine that you are the director of a New York City Taxi Operations Center. Under your purview, you have three different types of taxi fare that you purview over a daily basis. You have 300,000 of these, over 300,000 of these fares that happen each day. You have a fleet of yellow taxi vehicles, a fleet of green taxi vehicles, and you also keep track of the various for hire vehicles. This would include Lyft, Uber for hire, such as limo drivers. And you've got tens of thousands of these vehicles in your fleet, and you're responsible for tracking the activity in the city. You're responsible for the efficiency of the fleet and making sure that you're providing the maximum customer service as possible. You and your team have set up a very simple data flow where as the day progresses, 24 hours a day, 7 days a week, each one of these fares that occur gets streamed up into a bucket, a cloud storage into the cloud. And from there, you're using Databricks to monitor the data. And each one of these three personas handles and approaches the data in a different way. And what we're going to have is, an imaginary program management review from your New York City municipal leadership. And each one of our personas are going to give a presentation of how they interact with the data and what they do on a day-to-day basis. So first, we're going to start with Joe, the analyst. And Joe is going to investigate where the taxi drivers earn the highest tips. So that's the use case that he's going to present on today. The data engineers and the data scientists have made available this table, this materialized view called New York City Taxi Gold. And this is just a combination of the yellow taxi data sets and the green taxi data sets. And this is made available for Joe to analyze in his business intelligence tool of choice, Power BI, which is a Microsoft product. And as you can see, you have various, a lot of columns. Some of them are the pickup and the drop-off location, the date and time of each one of those. But the one field that I'd like to highlight is this tip alert. Elaine, your data scientist, has put together a predictive analytic algorithm to highlight when a fare receives a high tip, a higher than normal tip. And she's using predictive analytics to predict this, in particular a linear regression model. And we'll get back to that when Elaine does her view of the brief. But this is for Joe, and Joe has essentially table data available to him. Now, the way that Joe gets to this information is via a cluster. The cluster is a Spark cluster. And in that Spark cluster, all he knows is that he needs some sort of connection to this cluster to view this data that's been created for him. And so each cluster has the ability to connect. And a BI tool typically is going to connect through a JDBC or ODBC connection. He knows that he needs to take some configuration from that and enter it into his BI tool of choice. Databricks has the capability of interacting with multiple BI vendors. Power BI is one of them, Tableau, and so forth. But you can make this ODBC connection and connect it to the Spark cluster to view the data. So Joe brings up Power BI, and the first report that he puts together is just a passenger count by pickup date. And each one of these fares, there's a count of how many passengers are in each car. And you can see that for February 21st, approximately 426,000 passengers took a ride in New York City that day via some sort of taxi offered by the city. And so now he wants to analyze the tip alert made available to him by Elaine. So we take a look at by the various pickup zones, how many of these fares for the date of February 21st received a high tip alert or tip amount. And you can see it's clustered against both the airports and less so against some of the zones that you'd find in Manhattan. So let's take a look at and map out the tip amount versus the trip amount. So the trip distance to see if there's any correlation there. And this represents the tips greater than 0. And we can see that a lot of the high tips are clustered around trips that lasted between mile 8 and mile 12. What you would find is that most of the trips between 8 and 12 miles from LaGuardia Airport, and these are trips from LaGuardia Airport that originated from the LaGuardia Airport zone, it's about 8 to 12 miles to Lower Manhattan from LaGuardia Airport. So you imagine that a lot of the rich Wall Street guys are probably good tippers. So if a taxi driver could obtain a fare from LaGuardia heading down to downtown Manhattan, you increase your likelihood of getting it to high tip. So this is just a representative use case for Joe, the analyst, and how he uses Databricks and the combination of a BI tool to answer some sort of question. So next on our list is Elaine. Elaine's a data scientist, and a data scientist does a lot of experimentation to try to come up with some sort of predictive analytic based on the large amount of data that's received from the streaming data received on a daily basis. So let's go back to Databricks. And in Databricks, there's a capability called MLflow registry. And MLflow is as you may or may not know, MLflow is intended to make the various workflows of a machine learning or a data scientist automated and help across an enterprise set of data scientists. And this one, she has created a predictive taxi tip model that takes the number of passengers, the trip distance, and the pickup zone, and to try to predict what would be a high tip amount for that. And she's registered that model into the MLflow registry. So imagine if you've got a whole suite of data scientists, this gives them a consistent way of publishing out that model so that they can share that information with data engineers and across their team. If we take a look at the latest version, we're presented with various metadata, when it was registered, the last modification, who was the creator, and so forth, and including the run or the notebook that produced this model. You can also take and request this transition. Let's say usually it's going to be in a staging area first. You may want to request that it gets transitioned to production. And you can track all the activity that happens on this model. So you may have some sort of continuous integration process that does some sort of A/B testing on this model. And these stages, transitions, can be automated. And we have a whole API that allows you to interact with this MLflow registry. This is the actual notebook that Elaine created to help with the prediction of the taxi tips. The only thing that I'd like to highlight with this one is that we've scheduled a automated job. And what this does is spin up a Spark cluster and runs this particular notebook. And at the end of this particular job, which runs every day at 8 a.m., the last step is to register this model with the MLflow registry. So you can have a daily or periodic automated job that produces an MLflow model and then registers that with the registry. What does it exactly register? Well, let's see. This is a experiment tracking capability found in MLflow, and this records all of the various experiments run with this particular notebook. If I open just the most recent one, what I can see is various metadata associated with this experiment, this particular notebook. One thing I'd like to highlight is run against the previous 30 days of taxi data. So in this case, we ran over 1.6 million taxi runs against this data. And the other part of MLflow that's included are the MLflow models. And this is a generic envelope that houses the machine learning model. This could be, in this case, what we've created is a linear regression model using Spark ML. But this is generic. This could be a TensorFlow model. It could be a Keras model. But it's really just an envelope used to hold that model and distribute it out to the team. So this is how Elaine distributed out this model for the data engineers to then apply to the data pipeline, which brings us up to our last and final person is Jane, the data engineer. Jane has set up a multi-stage data pipeline to take the data that's being streamed into cloud storage and to form the data into a data form, which is that New York City taxi gold data that was used both by Joe, our analyst, and Elaine, our data scientist. I'd like to quickly just step through each one of the stages. If you haven't already, if you're familiar with Delta Lake, what we recommend is what I call the Olympian architecture, where we go through a bronze to silver to gold transition of how we take that data and further modify it so that it's cleaned up for those end users. And I'll just briefly talk about each stage here. So Jane is first getting the data from the yellow taxi set, the green taxi set, and the for hire vehicle taxi set, and she's getting it into a Parquet format. So the first step is to get this into Delta Lake, because Delta Lake provides various features such as schema enforcement, ACID transactions, the ability to time travel and roll back if you need to. And we have an Apache Spark cluster that is auto size. So if, let's say, you get a surge of traffic one day and you need to increase the horsepower of your data pipeline, it can auto size out to the correct size of nodes to process that data. So we're streaming that data from Parquet in real time into our bronze data set, which is really just transforming our data from Parquet to Delta Lake. Our next stage is what I call the silver or master. This is where we begin to shape the incoming data. In this one, the yellow and the green taxi data sets just represent the taxi zone lookup as a numeric number. In this stage, you'll routinely have to join your data with other taxonomies and other data sets to further enrich your data. So in this stage, we're doing 4 steps. The first is to rename the columns in bronze yellow and bronze green so they have a consistent data dictionary. We then take those 2 data sets, yellow and green, and we create a union across those data sets to create one big table. We finally join this unionized table into the taxi zone lookup, so we actually have the names of the taxi zones, so that when we do broadcast this information out to a BI tool, we can have those taxi names in the materialized view. We then write this into a silver table, and we call this New York City Taxi Silver. Sometimes you will have data scientists that operate on these silver tables, depending on their technical capability, or they may take a finalized gold table and use that instead. Again, I'd also like to highlight this is also a streaming data table. So as data streams in from our landing zone from bronze, it gets streamed into silver as well. Finally, we have our gold stage. In this one, we have data streaming in from the taxi data. And then at this point, we're taking the machine learning model that was registered by Elaine, our data scientist, and we're applying that to our silver table. So what that allows us to do is to put an upper bound of what would be considered in this silver table, we have a tip amount. And what we wanted to provide is a predicted high taxi tip amount. And we use a machine learning model from the MLflow registry to help us make that prediction. And if the tip amount is above that threshold, that's where we set the original tip alert flag to either true or false, which was used by Joe, the analyst. This finally gets written out as a gold table, also in our cloud storage, which is made available to both our analyst Joe and Elaine, our data scientist, for further experimentation. In addition, Jane, our data engineer, can also take this data and stream it to other upstream use cases. For example, she may go and stream this data to a geospatial service like Esri, or make it available to something like Esri Insights, or another BI tool like Power BI or Tableau. In addition to dashboards that you can run in external BI tools, you can also have dashboards running within Databricks. In this case, we've created a simple dashboard to give us a status dashboard on our Delta Lake pipeline. We can see both the incoming data messages that are coming in. We can provide a yellow, green, red status for when a pipeline could go down. And we've got similar types of metrics for each one of our incoming data sources, looking at the silver table and also looking at the gold table. So this would be a dashboard mainly for our data engineer, Jane, to use to provide situational awareness over our data pipeline. But we can also provide a dashboard, a simple dashboard for providing some of the similar information that you find in a BI tool. So in this particular dashboard, we're showing the number of customers that are taking a taxi ride throughout the day, and this data, as this data is streamed, you can update the data for that with that information. And then this one, we're just showing per zone how many passengers are taking taxi rides within a zone, and how many of those would be a high tip amount. So just to recap, Joe the analyst was able to use Databricks to take a look at throughout the data catalog that's presented in Databricks. He was given access to a gold table to allow him to run queries on that materialized view. Because it's using Delta Lake as a representation of that gold view, you could have additional indices on that table for query performance and reliability. He was using Power BI to produce his reports. We had Elaine, the data scientist, who was using MLflow to register the model that she created to predict taxi tip amounts. She was able to run a scheduled job every day so that experiment that she wrote could be pushed to production. And finally, we have Jane, the data engineer, who created a Olympian architecture bronze, silver, gold data pipeline that gives you a reliable way of shaping your incoming data and making it available to those downstream users who can utilize that data to come up with further insights into their data. I want to thank you for listening today. I hope that you've enjoyed this session, and along with the other sessions that you'll view during the Spark AI Summit. I've provided the GitHub account where I've got some of these dashboards, some of the notebooks available. If you would like to take a look at the code, I encourage you to take a look at this GitHub repository if you'd like to read the code. And I appreciate you listening today. Thank you very much.